Hi everybody, it's Miss Lorenz. I'm going to go through the lesson 6 work, the 5 problems. You should be checking your own work, correcting, and all of that. All right, so to start with, we are to find the area of each parallelogram. Each parallelogram here shows a base and a height. So the first one is pretty straightforward. 10 is the base, 6 is the height, and 10 times 6, of course, is 60. These are centimeters squared. In B, a piece of information that we don't need is on here. And I think that sometimes you might move too quickly and right off the bat think that 10 is your base. It could be if we had a height corresponding to 10, but we don't. So again, you always have to look for that base height pair. So in this case, 15 is the base and 8 is the height. Do you see how 8 and 15 meet each other at this 90 degree angle? And that's what you always want to find. 15 times 8, well, 2 15s is 30, so 4 groups of 2 would be 120, and these are square centimeters. All right, let's go to the next one, C. This is another problem where there are 3 measurements here. So our base is 9. And we're looking for the base height pair. And so we're looking for where do we meet at a 90 degree angle. There's our 90 degree angle. We know that 9 is parallel and identical to this side right here. So either of these right here can be the base. So we're just going to multiply 9 times 7 and we get 63 square centimeters. And then in D, we're going to multiply our base times our height. I'm calling this the base. It is 7. To get the height, I went to the opposite vertex. I came down perpendicular to where it formed a 90 degree angle with the base, which I had to make imaginary, and I get 35. These are centimeters squared. Alrighty. In parallelogram B of the first question, what is the corresponding height for the base that is 10 centimeters long? Okay, so that's interesting because in order for us to find the corresponding height to this base of 10, then we need a line that is formed at a perpendicular 90 degree angle right here or right here. And we don't have that. So we don't know. We can reason that it's going to be less than 15, but we don't know because obviously 15 is going to be a little bit longer since this side is diagonally positioned, but we don't know. So when it says what is the corresponding height, so there's no height given, we can reason that it's going to be less than 15 centimeters, but no, not enough information is given for us to exactly answer that question. All right, number 3, you had to draw 2 different parallelograms, P and Q, that have an area of 20 square units, and neither parallelogram should be a rectangle. So you guys, what I did is I thought of what are the factors that I can multiply together to get 20. I can multiply 4 and 5, I can multiply 10 and 2. So to make the 4 and 5, I went 5 here. And then rather than going straight up 4, because that would be a rectangle, I just went diagonally 4. And so I just chose to go over 3 and put a dot. And so the height here is still 4. And then I just connected 5 over and down. And so this we'll call P. We'll call this one Q. I did the same thing with 10 and 2. I positioned it so that my 10 was on a grid line this direction, and then I just went over 1. So then I went back 10 and over 1. And those look super sloppy. I'm still getting used to writing with my little magic pen here. All right, number 4, here are the areas of 3 parallelograms, and you have to use them to find the missing length. So in A, our area is 10, and in order for the area to be 10, then we know that we have to multiply 5 times some number to get 10. Well, we know that 5 times 2 is equal to 10. So 2 units has to be the answer for the height of A. For B, we're missing the base. B is, they're trying to trick you. Do you see where they're trying to trick you? So they gave us that the height is 7. The base, we multiply by 7. We know 7 times what is 21? 7 times 3 is 21. And so the base has to be 3. But do you see this? They labeled that little part a 1. I'm not sure why. I think it's just to trick you guys into thinking maybe that's a number that we're supposed to use. Stay with what you know. You know that we only need the base and the height. So 3 units. Same with this one. So if the area is 25, then we know 5 is the height. Well, 5 times what is 25? 5 times 5, of course, is 25. Again, they gave us this number just to make us really think and reason about what numbers we really need. Okay, and the last one. Oh my gosh, I think this problem is so fun, you guys. Okay, so in this problem, you have a large parallelogram composed of smaller parallelograms, and I hope that you took some time to really think about this. Even if you weren't able to solve it totally, I hope you gave yourself some good practice and perseverance trying to get there. In this one, we have these 4 parallelograms, and I just want to highlight this one right here because it has everything we need to get started. It's a 5 base by 2 4/10 height, and 5 times 2 4/10 is 12. The reason that's such lovely information is because all of these parallelograms are identical in size. So we know that those 4 parallelograms together, 12 times 4, have an area of 48. So what we're going to do is we're going to find the area of the entire parallelogram, and then we're going to subtract the 48, and then we'll be left with that middle area. Okay, now that I messed that up, I'm going to erase it, and hopefully you will be able to see what we're doing. Okay, erase, erase. Alrighty, so here we go. We know that this is 12. We know this is 12. And I'm talking about the area. We know this is 12. Well, we also know, you guys, that this is 3. And if that's 3 and that's the base, then the height has to be whatever we would multiply 3 by to get 12. 3 times what is 12? 3 times 4 is 12. So we know, sorry about that. So we know that this distance right here is 4. Do you see where I'm going with this? We want to find a height for the whole big parallelogram. We have the base. It's 8, right? Isn't 5 plus 3 8? But now we need to find the height. Well, we're partway there. We know from here down, the height is 4. It has to be 4 in order for this parallelogram to have an area of 12, which we already figured out is true. So now we just need to know this section. Well, we already figured that out because it's right here. It's given to us, that information. That parallelogram is identical to this parallelogram. These guys are partners. They're identical in size, identical bases, identical heights. And that means that this part of the height is 2 4/10. So to get the total height there, we need to add 4 and 2 4/10, and we get 6 4/10. So we're going to multiply 6 4/10, that's the height, times 8, which is our base. And 6 4/10 times 6 4/10 times 8. I'm just double checking my math here. Yeah, that's what I thought. All right, so it's 51 2/10. And these are inches squared. Okay, so what we just found is we found the area of the entire parallelogram, the entire thing, everything that I'm coloring in. Now, all we want, though, you guys, is we want that middle part, that white part. So what are we going to do? We're going to take the 51 2/10 and we're going to subtract 48. Why are we going to subtract 48? Because 48 was the sum of all 4 of those parallelograms. And so when we subtract, let's make sure we show the subtraction sign, 48, we're left with sorry guys, I just want to make sure I'm double checking this and it didn't look right to me. Yeah, okay, that's right. 3.2, right? 50, 51. Yep, that's right. 3.2. And so that means that 3.2 square inches is the area of that little parallelogram. Isn't that slick? So the question is, what is the area of the unshaded parallelogram in the middle? It's 3 2/10 square inches, and that was a fun problem. Hopefully it stumped you, but that you got to practice some grit and perseverance, and you're feeling better about that. All right. Good job, everybody. Thanks for watching.